And now for the AC driven inductor. Let's see, so again we have our AC source here, and now we're going across an inductor L, and this is again delta V. The voltage as a function of time is delta V max sine omega t. Well, what's going to happen? Well, let's not get into it too much. Let's say delta V, the voltage across, has to be across the inductor, so it has to be equal to L di dt, according to the freshman textbook. And then we start plugging in, solving for things. This is, of course, delta V max sine omega t equals L di dt. And to solve this one for the current, you always want to get to the current, you're going to need to do an integral. So let's see, so we're going to keep di over here and put everything else on the other side. The dt comes over, the L comes over. It's delta V max over L sine omega t dt, and then integrate both sides, and you get that the current, we aren't dealing with boundary conditions at the moment, these are just sinusoidally oscillating things. The current would be the integral of this is negative cosine, and you divide by an omega, so minus delta V max over omega L. The sine became a cosine omega t. So there's your oscillating current, delta V max over omega L, and it's a negative cosine. So let's now look at our plot of the delta V you applied and the current response in time. So the delta V you applied is a sine like that. And this time, the current is 90 degrees out of phase again, but it's a negative cosine. So it starts down here like that, and then it's going to come up and hit 0 when that one is there, and it's going to hit its max when that one is at 0, and then it's going to do something like that. Like that. So this is a horrible choice here. So delta V is right there, and I is right there. So again, they're 90 degrees out of phase, and the current lags the voltage this time. And you can see why. Here at time equals 0, we move along. The voltage is already going up to peak, and the current is still stuck negative and making its way up to peak. So our current is lagging the voltage by 90 degrees or pi over 2, whichever you prefer. So it sort of does the opposite of the capacitor in that sense. It gets them out of phase just in a different way.